Hey, we have here today another integral from the UNSW Integration Bee 2022. This was knockout round 2, problem 4. Okay, we have this integral on the board and we're integrating from 2 to log base 2 of 6. The thing I noticed right away is we've got a lot of 2 to the x here. We have one here. We have 2 to the x here. We have 2 to the x here. Now this actually can be written as a 2 to the x squared, and this also has a 2 to the x in it. So I'm thinking if I can do a u substitution on this, we're going to end up basically with just 2 polynomials in the numerator and denominator. So I'm going to want my u substitution to be just 2 to the x. And what I can do is take my 2 and write it as e to the ln 2, and then we still have our x here. And then if I take a natural log on both sides, we end up with natural log of u equals just natural log 2 of x, and then we can just solve for x, and x is going to be natural log of u over natural log of 2. So we're going to have here dx. Now natural log of 2 is just a constant, so we'll have that. And then the derivative of natural log of u is just going to be 1 over u. So we'll just write the derivative as 1 over natural log 2 times u du. And one other thing I want to do before I actually do the substitution, I just want to notice if we have 2x squared by exponent properties, this can be written as 2 to the 2x, or we can bring this exponent on the 2 and we can write this as 4 to the x. And so again, 2 to the x is just u, so this expression of 4 to the x can be written as u squared. And so that's just so that we know that this right here is going to be u squared. And the other one I'm going to deal with is just this one right here. Now we can take 2 to the 2x plus 1 and we can just write that as multiplication. We can write this as 2 to the 2x times 2 to the 1. But now we just found that this here was u squared, so we can actually write this whole thing as 2u squared. Okay, so now I'll go ahead and make my substitution. So the first thing we have to deal with is this upper bound, which is a little complicated. So when we plug this in for x, we're going to have 2 to the log base 2 of 6. But notice we have the same base here and the same base here. So this is actually the same as just 6. So our upper bound is going to be 6. And then plugging a 2 in here, 2 to the 2 is going to be just 4. Okay, now this value here we had determined was 2u squared. So we're going to have 2u squared minus 9. This is just u minus 6. And then here this is going to be just u squared minus u minus 6. And for our dx value, we're going to have basically 1 over u du, and I'm going to take this ln 2 and I'm just going to bring it out front of the integral. Okay, next just notice that I've rewritten this, but I just factored my denominator. I rewrote u squared minus u minus 6 as this u minus 3 times u plus 2. But now what that's going to do is we're perfectly set up to use partial fractions. And now at this point I've got my partial fractions set up over here on the right, and we just want to find our values for a, b, and c, breaking this up. And what I'm going to do for this is use the cover-up method. So let's just start with u. What we want to do for each of these 3 terms in the denominator, we want to figure out what will make it 0. So if I plug a 0 in for u, and I cover up that u, right, because we don't want to divide by 0. So if I take my 0 and we plug it in here and here, well, we're going to have minus 3 times plus 2 is going to be minus 6. We plug a 0 in for everything. We plug a 0 in the numerator. We're going to have a minus 6. So minus 6 over minus 6 is going to give me just a 1 for my a value. Then doing the same thing for u minus 3, we'll have to plug a 3 in. Now we have to cover up that term, but we'll plug our 3 in here and a 3 in here. We'll have 3 times 5 is 15. And then plugging a 3 into the numerator, we're going to have minus 15. So for our b term, we're going to end up with minus 1. And then if you do the same thing on u plus 2, you plug a minus 2 in there, but you cover up the u plus 2 and you plug a minus 2 into everything else. For our c value, we end up with 2. Okay, so now we just have 3 easy integrals in order to finish this off. So I'm going to keep my 1 over ln 2 here out front for everything. So for our first integral, we're just going to have 1 times natural log absolute value u. And then for our second integral, we're going to have just minus 1 natural log of u minus 3. And then for this last one, we're going to have our 2 out front for the c value, and then we're going to have natural log of u plus 2. And I'm just going to evaluate all this stuff. I'll just evaluate it all together, but it's the same balance. We'll evaluate it from 4 to 6. Okay, now we can just evaluate in order to finish this off. So first plugging in 6, we're going to have natural log of 6 minus, here we're going to have natural log of 3 plus 2 times, here we're going to have natural log of 8. Now plugging in our 4, we're going to have minus natural log of 4. Plus, I'm just changing the sign by distributing through with a minus sign, so this is going to become a plus natural log of 1. And then here we're going to have minus 2 natural log of 4 plus 2 is going to be 6. Okay, now natural log of 1 is just 0, so I'm going to get rid of that one. So we have 1 natural log 6 minus 2 natural log 6 is going to be minus 1 natural log 6. I'm going to cancel this one off here. And then I think I want to get everything in terms of natural log 2 and natural log 3. So like natural log 8 I can write as natural log 2 cubed, and that's the same thing as 3 natural log 2. And for this one, for natural log of 4, I can write that as natural log 2 to the 2, or 2 natural log 2. So let me just rewrite this. We're going to have this up front. Now natural log of 6, I can write that as, so 6 can be written as 2 times 3. So we're going to have, I can write this as minus natural log of 2 minus natural log of 3. Then I'll break down this natural log of 3. So natural log of 8 I have is 3 ln 2 times 2. So this is going to be 6 natural log of 2. And then we'll have this minus 2 natural log of 2. So let's just combine like terms. So when I distribute this in, the natural log of 2 is going to cancel. We have 3 minus 2 natural log of 3 over natural log of 2. But I think I'll write this the way they have it in the answer key for UNSW. So for the final solution, we're going to have 3 minus 2 log base 2 of 3, and that's it. Okay, good problem. We'll stop it there. Thanks everyone for watching. Have a great day.